So we are given a head of a singly linked list and an integer k. So we have to split the linked list into k consecutive parts. So the length of each part should be equal as possible, and no two parts should have size difference of more than 1. So it is mentioned that it may lead to some null part also, and parts should be in order of occurrence in input list, and the part occurring earlier should always have a greater than or equals to. For suppose this is the example, so the earlier in earlier segments can have extra linked list, and the difference should be 1 only. Like earlier, in the earlier part of this answer output we have 1 element, and the later part we have 0 elements, but the difference is always 1. So let me take you to the notebook to explain this. We have our split linked list part, and suppose we are given this linked list. So, and the k is given as 3, which means that we have to make segments of this linked list such that every segment have k nodes, which means if k is equals to 3, every segment will have 3 node. Then we have 3 node, then we have 3 node, but we have some extras, so we have to include those extras in the starting of that answer. So our answer would look like 1 2 3 4, then one more segment and the third segment. I will give you one example of this second example, that we have given 1 2 3 node and k is equals to 5. So what we have to do is we have to make k is equals to 5. So we have our answer as 1 2 3 and empty, because we have to divide it into 5 parts, and we will have zeros also, or the null also included. So let me focus again from the starting of this example. So to find node per list or node per segment, we have to divide the size of this whole node by the value of k, which is 10 divided by 3, which is again equals to 3, which means that we will have 3 segments full-fledged, and the amount of extras, which means the extra node in the segment, will be calculated by n mod k, which will be 1, which means that among these three segments, one will have an extra element, and that extra element will be included in this, always included in the starting of that answer. So this is how we will calculate our answer. And let us come to this part now, the second example. So suppose we are given k is equals to 5, and these 3 elements of list are given. So nodes per list will be n divided by 3, which is 0, which means that in our answer we have 2 3 and null values, by which we means that 0 elemented per list we will have 0 elements, and extras will be equals to n mod k, which is 3 mod 5, which will be equals to 3, which means that these 3 after those empty or null nodes, we will have 3 nodes which will have 1 extra element. So this will be that. So now let's move and we will see how we will do a dry run. So we will put, first of all we will count the size of this linked list. Then what we will do is put traversal t over here. and after that we will put this t into answer, our answer node. After that we initially we will definitely calculate node per list and extras also. So we will make our node is equals to node per list minus 1, which means that if it is 3 we will make it 2, and then we will check if we have any extras. If yes, we have extra, so what we will do is we will increase this from 2 to 3, and we will decrease extra by 1, and this will happen until extra becomes 0. So now until this node value becomes 0, we will traverse this t to next. So it will become 2, it will come over here, it will become 1, it will come over here, it will become 0, it will come over here, then again we will check that it is 0, so we will not move further. So when t will be here, what we have to do is we have to create a next pointer which will be traverse next. We will make this as null, and at starting we have inserted this traversal's head into the answer, so it will be present over there, and then we will make this t as n, and we will continue our loop again. The corner case which we should take care of is that at the last of our answer, if our answer dot size is less than k, we will keep inserting null. Why? Let me show you here. K is equals to 3, then whole of the number of segments will be 3, and if k is equals to 5, the number of segment will be also equals to 5. So in case we don't have any, if this answer dot size and k do not match, we will have to intentionally push null into it. So this is how our answer will look like. We will have our list node as answer, and this whole process is for calculating the size. And then at head, like we will put a pointer traverse at the head of the linked list, and we will calculate node per list, and then the extras, which will be n mod k, size mod k, and then we will start traversing our node, this to this. So now what will happen is we will push the traverse to the answer, and we will create an int node and node per list minus 1, and if extra is present, so we will increase the node value by 1 and decrease the extra by minus 1, and then move the traverse to its next until node becomes 0. So this is how, if we have, like over here we have traverse and node is equals to node per list is 3, so we will, and we have 1 extra, so we'll make it 4, and we will traverse it from 4, 3, 2, 1 until it becomes 0, and it will take from 1, 2, 3 and 4 steps. And this is the whole process of switching the pointers. This will be the corner case. We have to check carefully. This is how our answer will look like.